Hello everyone. Are you good at mathematics? Today I'll share with you the scholar Richard R. Skemp, a great pioneer theorist in the psychology of learning mathematics. I'll lead you to know who is Richard R. Skemp, and I'll introduce to you his learning theory in mathematics, his instrumental understanding and relational understanding, and later we'll talk about his inspirations for our language learning and teaching. Richard Skemp was a unique figure in mathematics education. He's a significant inspiration to a vast number of teachers and educators who have gained insight through reading his books. And his moving spirit in the foundation of the International Group for the Psychology of Mathematics Education. His background peculiarly fitted him to the role of a father figure in the psychology of mathematics education, for he was qualified as a psychologist, a mathematician, an educator, a practicing teacher, an empirical researcher, and a theorist. He was born in Bristol on March 10, 1919, the son of Professor A. R. Skemp of the University of Bristol. He was educated as a foundation scholar at Wellington College, Berkshire, taking up an open scholarship in mathematics at Hertford College, Oxford in 1937. The war later intervened and he joined the Royal Signal and serving in India and attaining the rank of captain before returning at the end of the war. He then completed his degree at Hertford College from 1945 to 1947 and became a mathematics teacher for 2 years at Oundle School, followed by 2 years at Rice St. Anthony, Oxford. His increasing interest in how children learn caused him to return to Hertford College at the age of 33 in 1952 to study for a second bachelor's degree in psychology. He completed his PhD in psychology at Manchester University in 1959, where he was first a lecturer in psychology and subsequently senior lecturer, directing the Child Study Unit. In 1973, at the age of 54, he became professor of educational theory at the University of Warwick, where he remained until his retirement in 1986. Talking about Skemp's works and papers, his book, The Psychology of Learning Mathematics, published in 1971, has been translated into Dutch, Hungarian, Spanish, Japanese, Chinese, and Greek. His later book, Intelligence, Learning, and Action, published in 1979, offers a new way of thinking about human intelligence and its relation to schooling and education. These two books formed the basis of an 8-year project funded by the Nuffield Foundation and the Leverhulme Trust, began in 1978 and called the Primary Mathematics Project for the intelligent teaching of mathematics. Richard Skemp prided himself on the quality of his output, polishing his work for some time before releasing it for publication. For the following papers, I'd like to introduce 3 to you briefly. His mold-breaking paper, Instrumental Understanding and Relational Understanding, was presented in talks for several years before it reached its final form. It is no wonder it continues to be a seminal paper so many years after it was written. Later, I will talk about the ideas in this paper. Another paper, Reflective Intelligence and Mathematics. This paper is an attempt to continue into the field of mathematics the kind of psychological analysis that Piaget has made in that of number. Differences between arithmetic and mathematics are related to the differences between sensorimotor intelligence and reflective intelligence. The latter concept is developed further, and an experiment is described to test the hypothesis that the transition from mechanical arithmetic via problem arithmetic to mathematics involves the transition from sensorimotor to reflective intelligence. In the paper, the need for schematic learning theory, Skemp states, current learning theories have little direct application to problems of teaching and learning school subjects. The development of a schematic learning theory will, it is hoped, help to remedy this deficiency. Such a theory will also have wider applications. Now let us move on to Skemp's theories. Richard Skemp was a mathematician who later studied psychology. He drew on both these disciplines to explain learning in mathematics. The main thrust of his argument is that learners construct schemata to link what they already know with new learning. According to Skemp, mathematics involves an extensive hierarchy of concepts. We cannot form any particular concept until we have formed all the subsidiary ones upon which it depends. So that is to say, intelligent learning involves building networks of schemas that enable us to achieve our goals. Our schemas are cognitive or intellectual structures. In mathematics, in the primary school, he likened the process of schema construction whereby humans build their concepts and processes to that of building a brick wall, while periodically testing its alignment. So a schema is a conceptual structure existing in its own right, independently of action. He described his intellectual schema construction in terms of building and testing. Well, we'll take a look at the following contents. At the heart of Skemp's theory of intelligent learning and reflected in the design of the activities are three modes of schema constructions. Schemas, connected groups of ideas, are constructed at the mode 1 level by building from physical experience and testing to see whether predictions are confirmed. Mode 2 schema building proceeds via communication and testing through discussion. Mode 3 schema construction involves mental creativity and testing of new ideas for consistency with what is already known. The third, invisible component structure is particularly important for learning mathematics with understanding. To understand something is to relate it to what is already known. That is an existing schema. With the right prerequisite knowledge, intelligent learning is possible. The new knowledge becomes part of the schema to which it has been assimilated. The schema expands and new things can be learned with understanding which could not have been understood before. Without the prerequisite knowledge, intelligent learning cannot be applied, and the result is rote learning or no learning at all. Here is a sample of the ideas that guided Richard Skemp as he developed his theory of intelligent learning and applied it to the needs of the elementary school mathematics curriculum. One cannot learn a concept with understanding unless one has the appropriate schema to which it can be attached. And primary concepts are abstracted from direct sensory experience. Secondary concepts are abstracted from primary concepts or other secondary concepts. Well, so after talking about his schematic learning theory, so we'll move on to the next part. Skemp's theory basically highlights the differences between instrumental and relational learning in the math classroom. Skemp introduces relational understanding as knowing both what to do and why, and instrumental understanding as the ability to execute mathematical rules and procedures. So that is to say, instrumental understanding, it is a mechanical rote or learned rules. While in the relational understanding, it is a more meaningful learning in which the pupil is able to understand the links and the relationships which give mathematics its structure. While it's easier and tempting to teach techniques in a non-relational instrument manner, which even if successful in helping a student pass an exam, will sooner be discarded after the exam and not provide a firm foundation for a student to build on in their further education. Skemp admits his long-standing assumptions that relational understanding is better. But the question is then, when so many mathematics teachers and texts focus on instrumental understanding. So, despite his preference of relational understanding, Skemp proposes 3 advantages of instrumental mathematics that make it preferred amongst many mathematics teachers. That is, number 1, within its own context, instrumental mathematics is often easier to understand. Number 2, the rewards for following a procedure and getting a correct answer are more immediate. Number 3, because less knowledge is involved, its often correct answers come more easily and reliably. In contrast, Skemp identifies 4 advantages to relational mathematics. Number 1, it is more adaptable to new tasks. It is easier to remember, and the relational knowledge can be effective as a goal in itself. The last one, relational schemas are organic in quality. The preference or use of instrumental mathematics by teachers are many, says Skemp. In some cases, instrumental understanding comes more quickly, and for a particular calculation in a class or on an exam, it may be all a student needs. The expectations about the nature and amount of content presented in a course can also influence a teacher's use of instrumental mathematics if they feel pressure to cover many topics. Teachers may also prefer instrumental understanding because it is what they themselves possess, or they have difficulty recognizing relational understanding in their students' thinking and written work. To set up a theoretical explanation, Skemp proposes an analogy. He imagines visiting a town for the first time and needing to navigate to particular locations. He compares two strategies: A. Learning specific routes that take him from where he is staying to his destinations, or B. Exploring the town in a way that allows him to form a mental map of significant landmarks and features. For getting from point A to B, the first strategy will be efficient, but limited to that route. The second strategy might result in a longer trip from A to B, but he will be more prepared to find other destinations and is less likely to get lost. Skemp relates the first strategy to instrumental understanding, where learning to navigate consists of learning an increasing number of fixed plans. Relational understanding is like the second strategy, where learning consists of building up a conceptual structure, that is a schema, from which its possessor can produce an unlimited number of plans for getting from any starting points within his schema to any finishing point. Schema therefore distinguishes relational understanding from instrumental understanding in the following ways. Number one, the means have become independent of particular aims to be reached thereby. Number two, building up a schema within a given area of knowledge becomes an intrinsically satisfying goal in itself. The more complete a pupil's schema, the greater his feelings of confidence in his own ability to find new ways of getting there without outside help. But a schema is never complete. As our schema enlarges, so our awareness of possibilities is thereby enlarged. Thus, the process often becomes self-continuing and self-rewarding. Many of Skemp's ideas have passed into the folklore of the subject, especially his use of the distinction between instrumental and relational understanding. But there are also other things that many find especially valuable. For instance, his simple descriptions of the notions of concept and schema. His use of the terms expansion and reconstruction of schemas instead of assimilation and accommodation. His three modes of building and testing mathematical concepts, his ideas of reflecting or intelligence in learning, and his links between the cognitive and affective sides of mathematics in his theory of goals and anti-goals. Richard had a special way of dealing with students' work. For instance, he would read a piece of writing with tape recorder in hand, making comments that he passed on to the student to study at leisure. It was so valuable to have his ongoing commentary and the possibilities of rehearing subtle comments several times over. So, Skemp provides great inspirations for our language learning and teaching, although he devoted his study all on mathematics instead of language. Finally, I want to emphasize that by Skemp's study on instrumental understanding and relational understanding, although instrumental teaching has its place, we should always be thinking about maximizing relational learning opportunities for our students. And by his study, we know we use mechanized repetitive learning is not enough. Students should be motivated to use their intelligence in learning to gain growth in order to be a successful teaching method. And also students' mistakes are encouraged. They should be seen as potential benefits of the learning process, not as sins. And as teachers, we'll try to provide a confident learning environment for students. Okay, well, let's my sharing about Skemp, Richard R. Skemp, especially about his study on the learning theories and relational understanding and instrumental understanding. Thank you for your attention.